So in this lesson, we're just going to go through a few more examples that are applied to Pythagorean theorem. The very last one is a challenge question, and there is a similar, it sets you up really well for the final question that is on your assessment. So I would strongly advise you to look at that question. Remember the gazebo that showed up before? Gazebos are coming back. So I'm going to give you every lesson, we're going to give you a few complex shapes because that's what we actually encounter in real life. It's not just simple squares. So we'll work through the first little bit and then we're going to, the first little bit should be pretty straightforward. The very last question, I want to make sure that you at least fast forward to example number 6 and work through that question with me. And if for some reason you find that there is a math glitch somewhere, please don't hesitate to let me know. I believe we discovered last week that we had some unknown calculator error on the go. So again, thank you very much for pointing that out. And should you see anything like that in the future, please don't hesitate to let me know. All right, so for the very first question, we're going to start with a couple easy questions just to kind of refresh us on where we use Pythagorean theorem and what it means. So this question, 3 sides of a triangle measure 9 feet, 16 feet, and 20 feet. Determine if this triangle is a right triangle. Remember the 3, 4, 5 rule? So if a triangle is a right triangle, there's two ways we can solve this one. If a triangle is a right triangle, so just waiting for my tablet here to connect. So a right triangle follows 3, 4, 5 for the sides. Okay, so that's a 3, 4, 5 ratio. Or for a right triangle, a squared plus b squared equals c squared. So those are two things we can use. So a right triangle will follow the 3, 4, 5 rule. So let's see, will this follow the 3, 4, 5 rule? 9, 16 to 20. I can divide 20 by 4. So let's divide it by 4, divide this by 4, and we'll divide this one by 4. So we know 20 divided by 4 is going to give me 5. 16 divided by 4 gives me 4. 9 divided by 4 is not a whole number. 9 divided by 4 gives us 2.25. So it is not 3, 4, 5. Therefore, not a right angle. Okay, so really simple question to check. The other way to do it is to plug it in using Pythagorean theorem. So if you look at your sides, if we were to draw the triangle, oh dear, my drawing is terrible here. We know the longest side's a hypotenuse, so we'll put that here. We're going to have 9 and 16. So if you were to write it out, a squared plus b squared equals c squared. A squared is 9 squared plus 16 squared equals 20 squared. Put this into your calculator. 9 squared plus 16 squared gives me 337. Should equal 20 squared, which is 400. That is not true. So it's not right. Not a right triangle. It's easier to draw symbols than it is sometimes to spell things out. Sometimes I'll abbreviate with that. Okay, so nice easy question to start. So that's a really simple one. Question 2, determine the diagonal for a concrete rectangular pad that measures 40 feet by 32 feet. So again, a nice easy question. Draw the rectangular pad out. So we have 40 feet by 32 feet. We want to know what's the diagonal. So you'll notice your diagonal is the same as your hypotenuse. So we're plugging into our formula. So you have your formula. If it's 40 feet on this side, we got 40 feet over here. So 32. So this is your A and your B. So 32 feet squared plus 40 squared should equal c squared, which is our hypotenuse. So if we put that into our calculator, 32 squared plus 40 squared gives us 2,624 equals c squared, and then we take the square root of both sides. So C is equal to 51.2 feet. If you want to do feet in inches, you will get 51 feet and 2 inches. Now, it's 2 inches, 0.2 feet times 12 is approximately 2 inches. It's going to be 2.4, which you round to 2. So it's not just changing the feet to inches just by putting inches where the decimal is. I actually did do the math out on that one. Okay, nice, easy question. Really simple. Those are the easy versions, but of course I'm not going to give you all the easy versions. And I think the assessment I'm starting with might be a little bit of the trickier one, but we'll see. A carpenter needs to square a wall before he installs OSB sheathing. If the wall is 55 feet long and 8 feet high, what's the diagonal measurement? So here's our wall. Now this is a scenario where I'd argue the 3, 4, 5 would make more sense for us, but this is going to tell us if the diagonal works, we know this corner is square, this corner, all the corners are square. So you have 55 feet, 8 inches, and then we have 8 feet over here. Now, because we have feet and inches in combination, you can change it to either decimal feet or all inches. If you change it to all inches, you're not going to have to deal with any decimals. So I'm going to go that route. So 55 times 12 plus 8 leaves me with 668 inches. 8 times 12 makes this side equal to 96 inches. To find the diagonal, this is our C. We're going to have a squared plus b squared equals c squared. So we have 96 squared plus 668 squared equals c squared. Now we're going to get a really large number, and that's okay. So if you put that in your calculator correctly, you should get 455,440 equals c squared. Now this number doesn't make sense. That's way too many inches. So we're going to take our square root. So you get a really big number and you go, heck, that doesn't make sense. Take the square root. So c squared is equal to 675 inches in length. Or we could say 56.2 feet, which is the same as 56 and 2 inches. Whoops, I left a squared on there. Excuse me. I'm going to erase that. We took a square root, so the square is gone. There we are. All right. So again, a nice, easy question. You guys are doing decks right now, I heard. So this is a really great question for figuring out stringer length. So stairs. Stairs are a common thing to have to solve for. So the height to the top of the deck is 48 inches. What length of stringer is needed from if the last step is 64 inches from the edge of the deck? So let's label our diagram. And drawing a diagram and labeling a diagram is really, really helpful strategy. So you know you have 48 inches to the top. And then we know here, this distance is 64 inches. So we have our right triangle. Okay. So to figure out our stringer length, our stringer is going to be C. So C squared equals A squared plus B squared. So C squared is going to be 48 squared plus 64 squared. That gives us C squared equals 6,400. And then take your square root. C equals 80 inches. We put inches in here, so we're going to get inches out. So we have 80 inches is the stringer length. Those are easy ones to see the triangle in. The last one's not so easy. Just giving you a fair warning. Make sure you stick around to watch that one. 5. The span of a house is 30 feet. If the length of the rafter is 18 feet 6 inches, what is the pitch written as a blank 12 ratio? Okay, I want you to round to a whole number. So first thing I'm going to do is 18 feet 6 inches. I can do is 18.5 feet. Okay, just simplify. Let's sketch our picture. Now, in order to write a ratio, this is my rise and run. I need to know what the height to the peak of this particular roof is. So we know the whole span is 30, which tells us that this is going to be 15. We're assuming equal pitches. Doesn't tell us in the question, but if it doesn't tell us, you can assume that, especially if you're not given a diagram. It's the only way we can calculate this. We know the rafter length is 18 feet 6 inches, or 18.5 feet. And what's the height? So you'll see you have a right triangle. So we're going to do our formula. A squared plus b squared equals c squared. Our hypotenuse is the rafter length, so that's our 18.5. Equals b, we'll say is 15 plus a. Okay. Let's move our 15 squared. This makes it so we can put it all in our calculator in one piece. So we're going to have a squared equals 18.5 squared minus 15 squared. Don't forget that squared. So a squared is equal to 117.25. Take our square root of both sides. Because it's a terminating decimal, I did keep all the decimal places. A is equal to 10.8 feet. So there's my rise. But we're not done the question yet because it wants to know the pitch. So we'll calculate the pitch over here. So we know, okay, we want it written as x over 12. That has to be equal to the real numbers. So for the real numbers, our rise was 10.8 and our run is 15. Cross multiply, 12 times 10.8 divided by 15. X is equal to 8.6, which is approximately 9. We can round that up. So the pitch equals 912. I know it's not quite a perfect 912, but it's pretty close, close enough for us. Okay. So you cross multiply, so 15 times 10.8, and don't forget to divide by the number left over, the 15 left over. So that's, by the way, you might want to come back to this example depending on which questions you choose on your assessment. Just a heads up. Last one is a challenge question. I'm going to get rid of our video so you can see everything for it. This question is going to really help you for one of the challenge questions in the assessment. So you always have to apply your thinking in new ways. That's part of what we test for. Those questions won't have as much weight as some of the simpler ones. But what I want you to work at here is I want you to calculate the area of the roof on this particular gazebo. Now you're going to have to kind of stretch your thinking a little bit, and I'll confess, some people are really good at this and other people struggle with it more, and that's understandable. So it's not going to weight you enough to fail you, but you do need to have an attempt on it, okay? Now I'm doing a complicated one that has 6 sides. You don't have one that's nearly as complicated. So let's start with this. A gazebo roof, that's not an uncommon thing for somebody to have to build. You could have a couple versions of roofs that have different shapes that come up and meet at a point. If you look at different roofs, we could have a square hip roof. That's 4 triangles that come up and meet at a point. The roof in my house in the sunroom where I'm recording this is 3 triangles that come up to a point and then it meets to the house. And there was a good little bit of trig that was involved in that. And that's where some of these questions actually come from, are real life examples that I've had to work at, had to calculate to figure out. And then of course we adjust numbers and maybe give you some different things to calculate from them. But there's some really good real life examples. So it's not uncommon. A mansard roof is a roof that's made up of several shapes, trapezoids, and then it's a square on top. So that's a mansard. You might find a hip roof that is a triangle and then a trapezoid together. That's another common one. So that's via rectangular hip. There's a bunch of different styles of roofs. And in order to calculate these, you'll often know the pitch, but then you're going to be missing some information. So we're going to use this octagon one, which is made up of 6 triangles, in order to show you how you would solve for some of the missing information, hopefully help you visualize what the triangles look like that we're trying to solve. So what is the area of the roof of the gazebo that is a hexagon? The roof has a 7/12 pitch. Each wall is 7 feet long, and the total width across measures 12 feet wall to wall. So I'm going to put some information in our diagram. If each wall is 7 feet, we can assume that this measurement is 7 feet. To find the area, I need to know what is the length of the roof along the diagonal. That is not the same as the height to the peak, unfortunately, because if we look here, that would be the same as this S. It's going to be longer than the height to the peak because it's along the slope side. That's like calculating your rafter length. So hopefully you can kind of visualize that. In order to find that, so if we take so this is S and this is my S here. We'll call them the same letter. So I'm hoping this 3D diagram helps you see that. So we have this triangle that's on an angle, and I'm just going to eliminate some of the pieces. Okay, and it'll help us figure out. So this is our triangle. I've just isolated one of the triangles here. S is the height to the peak, or the height to the peak, the distance along the roof to the peak. So that's like my rafter length. This is height to peak. And this is my distance to the center. Okay, so hopefully those make sense to you. I'm hoping you can figure those out. And we already know that the wall length is 7 feet. So let's label what other information we know. Wall to the center, well, it says it's 12 feet wall to wall, so wall to center is going to be equal to 6 feet. So now you can see we're starting to get our triangle. So if this is 6 feet, and S is like my rafter length, what is the height to the peak? So this is my slope, so I need to use my pitch in order to find it out. So to find my height to the peak, let's call this, we'll call it H, because it's H over here. To find height, height over 6 has to equal the pitch, which is rise of 7 over run of 12. 6 times 7 divided by 12 gives me my height, which is equal to 3.5 feet. So we can put that in here. Now that we have that, the height to the middle and the distance out to the center makes a right triangle. In order to find length S, we're going to use Pythagorean theorem. So a squared plus b squared equals c squared. A, we'll say, is 6 feet. So 6 squared plus b, we'll call b 3.5, equals, and our hypotenuse now is S. Okay, and I'll use the letter S just so you can line it back up with the sides. Putting that into your calculator, you will get 48.25. And double check my math here. 6 squared plus 3.5 squared, 48.25 equals S squared, and then take the square root of both sides. And we get S, the length S, is equal to 6.9 feet. Okay? So if we think about our triangle now, to find the area of this triangle, I need the height to the peak of the triangle times the base of the triangle divided by 2. So the area of a triangle is equal to base times height divided by 2. Well, the base in this case is 7 feet times 6.9 feet divided by 2 gives me an area of 24 square feet. 24 square feet times 6 sides equals 144 square feet. Okay, so that's my area. So it's a little bit complex. The hardest part is kind of visualizing these triangles, and I'm hoping that by sketching it out this way, it makes sense for you. In a roof like this one, this particular one, what I would do is, yes, you have a triangle that's on an angle, Okay, so that's one thing you're going to end up with. But for this one, I would think height out to the edge, there's my diagonal. So you can figure out your slope that way. The same thing for this triangle. Think of it just like I've drawn this one. Go straight down and then think out to the edge. So you kind of have to think in 3 dimensions. And if you need some help with that, let me know and I'll try to give you a little extra help with diagrams on it. But you will see a question like this. And because this kind of question is a complicated one, I can't really ask it in SAIL. But in your assessment project, I do ask you to stretch your learning a little bit, take an example like this and apply it to a new shape. So hopefully you'll be able to do that with success. Please, this is the first time I've done the roof area assessment this way. So if you have feedback or if you're getting stuck, let me know. And I'll happily discuss some of the scenarios with you. I won't give you the answer, but I may give you a couple of tips that will help you work through your calculations. But I do expect to see an effort at least started on it before you ask for too much support for answers. So hopefully that helps you out. Please, once again, let me know if you have questions.